All right, guys, this is a continuation of the introduction videos. This is going to be intro part 3. So from this, you're going to get your assignment regarding Charles's law. Your assignment is to do question number 6 on page 446 in your textbook. So that will be part of this assignment. The next law that we're going to talk about is Gay-Lussac's law. Gay-Lussac, here we are talking about a relationship between pressure and temperature. So again, this is the idea that P1T1 is equal to a constant, P2T2 is equal to a constant, and since that constant is the same, we can set those equal to each other and solve for what is missing. So we'll have to have 3 items given to us and solving for 1. Because temperature is involved here, we will have to convert any temperatures to Kelvin in order to proceed. So we are going to be working on page 448. So please turn there in your textbook and you can follow along. So our sample problem that I'm going to solve is number 8. This says the pressure in an automobile tire is 1.88 atmosphere at 25.0 degrees Celsius. What will be the pressure if the temperature increases to 37.0 degrees Celsius? So again, we're going to make a chart. So the beginning pressure is 1.88 atms. The beginning temperature is 0 degrees Celsius. The question is, what will the pressure be? So we know that that is our question mark. When the temperature increases to 37.0 degrees Celsius. All right, so we know that we cannot use a Celsius temperature in our equation, so in our formula. So let's go ahead and change these to Kelvin. So we're going to add 273. So 25 plus 273, give you a chance to follow along with me, is 298 Kelvin. And then 273 plus 37 is 310 Kelvin. And that's okay for those numbers right now because the original data is what's going to guide our sig figs. So we can just leave that 310, though technically it doesn't have 3 sig figs, but that will work okay for our math. All right, so since we're solving for P2, again, let's look. Your textbook would ask you to rewrite this formula. So if we rewrote this, the steps to rewriting it would be to cross multiply. So T1 equals P1 times T2, right? That's what we do when we, right? So those get multiplied by each other. And it's equal to these get multiplied by each other. I think you had a math teacher. Didn't you have a math teacher? Didn't Coach Presley call that the butterfly? Doing the butterfly there. So if we are going to solve for P2, then it's P1 T2 divided by T1. All right. So now we can plug in. So I'm just going to do this under here. So this gets us our pressure 2. We're solving for P1 is 1.88 atm. The second temperature is 310 Kelvin divided by the first temperature, which is 298 Kelvin. We see that Kelvin is going to cancel. We're left with atm as a unit. So that is the correct unit that we have there. So we're going to pick up our calculator. So 1.88 times 310 divided by 298 equals, and we have a slew of numbers here. So let's look at that. So this says 1.955, blah, blah, blah. So that 5 is going to make that roll up. So the pressure is equal to 1.96 atm. I have to put my unit with that there. Now quickly, let's just look at how would we show the work? I'm going to actually change colors here and let you see. So what would this look like? I'm actually going to change to red. What would this look like if we go just from here and we fill in? I'm sorry, to our original. So we go to P1, T1, P1, T1 equals P2, T2, and we take our data from the chart. So it's 1.88 atm over T1, which is 298 Kelvin, equals P2 is what we don't know, and then 310 Kelvin. So if we look at our idea of the cross multiplication idea, it means we're going to multiply those, right? And then we would be multiplying those. Then would be connected to our unknown. So we would divide by that, just like it stays down here, right? So if I fill in this, then we will go 1.88 times 310 divided by 298. And that gets us the same answer. P2 equals 1.96 atm. So hopefully you can see that whether you take the original equation and then you cross multiply, rewrite it to solve, and then you fill it in and you solve, we get the same answer if we are able to mathematically go straight from the fill in and then just chug the answer out on our calculator. But you have to do what makes sense to you. Either one of these processes is correct as long as you're showing your work. All right? So your task then, your assignment would be to do number 9 on page 448. That's your assignment related to Gay-Lussac's law.